Hi friends, every effort you make to learn will yield satisfying results. NMR stands for nuclear magnetic resonance. It is one of the spectroscopy tools. NMR can be used to determine the structure of molecules. How this tool works, watch this short animation. Every atom has protons. These protons are positively charged particles. When rotating on its own axis, a magnetic field will be formed. Because the movement of electrically charged particles will produce a magnetic field. The direction of this magnetic field depends on the orientation of the proton. That is why protons can be considered as small magnets. Just think of the proton in an area with an external magnetic field. The direction of the magnetic field is from the North Pole to the South Pole. If so, the proton will adjust the direction of its magnetic field to the external magnetic field. The two magnetic fields are in the same direction, but not in a straight line. This movement is known as precession. What's interesting about this process? When electromagnetic waves are directed at protons, if the energy matches, the energy of the electromagnetic waves will be absorbed by the protons. The protons will change to a higher energy position. The energy position is higher when the south pole of the proton magnet faces the south pole of the external magnetic field. We know that the same magnetic poles facing each other will move away from each other. So this high energy position does not last long. The electron spin will rotate to a lower position by emitting energy. This energy is a signal for NMR. This is a simple illustration of how NMR gets signals from protons. Then how do we apply this concept to our case? Atomic nuclei can have different numbers of protons. When the number of protons is even, then half of the protons are in spin-up state, the other half are spin down. We know that the magnetic field is a vector quantity. Two vectors with opposite directions have a resultant of 0. In order for the protons in the atomic nucleus to have a non-zero spin resultant, the number of protons must be odd. Among the elements listed on the question sheet, only carbon-12 has an even number of protons. So, the protons in the nucleus of a carbon-12 atom will have a resultant intrinsic magnetic field of 0. Atoms like this will not give a signal when used as NMR samples. The answer is B. Happy learning, everyone!